So I now want to discuss how to stabilize an active device. At the moment we consider only the load plane. So what does the stability circuit tell us? We have in principle the following situation. We have our active device. It's described now by our Y parameters or S parameters, and we connect to this active device our load impedance, or sorry, our load admittance, which is given as GL plus JBL. So it consists of a real part and an imaginary part, and we have here our load stability circuits in the load plane, and as soon as the load admittance come out of the stability circle in the red sketched area, then this will result in a negative input impedance. So I sketched here, for example, the stability circle for different frequencies, and we can now think of how or what condition our load admittance must fulfill that it may not enter, or that it not enters our stability circuits. So you see, the stability circuit, they move, and there may, for example, be one certain frequency where it's fast in the right half plane, and this will define a minimum load, GL min. This means to become stable, we will always have we must have, if we want to have stability, then we must have that the real part of our load admittance must be always greater than the minimum load admittance. So if the load admittance would fulfill this condition, of course, then it would never come into the stability circuits. And to assure this, we just have to do the following, that we say we take our active device, and now we add to our active device our minimum load, GL min, and we add a second load admittance YL prime. So the overall load admittance now, if I take the overall load admittance, independent of the real value of our new load admittance, you see we always would fulfill this relation. This means now for our load admittance prime, we would have that the real part of the load admittance prime must be just greater equal to 1. Also this this procedure we must have a look on in the with the help of the simulation tool. So in principle it's like this. So we have the stability circuits which move in the load plane, and the stability circuits which reaches farthest into the load plane will define a GL min, and if we put this GL min at the output, then we will move the stability circle. This will be see in the with the help of the simulation tool.